Okay, so in this video we're going to be doing every exam question that has ever been asked on volume and surface area, but to be particular on this stuff down here on cones and spheres, the things that come with formulae. So this document is fully hyperlinked, and as I always say, it's linked in the description. If it's downloadable as a PDF, so you can use it for all of your revision, and every single section has a video solution that goes with it. So let's have a look at what this question says. It says shape S is 1/4 of a solid sphere, centre O, and the volume of this is 576 pi centimetres cubed. All we need to do is find the surface area of S. They want to 3 significant figures, and we want to show all of our working. So we know that this shape is going to be 1/4 of the volume of a sphere. So I'm going to say that 1/4 of the volume of a sphere, which is 4/3 pi r cubed, and they always give you these formulae for these questions, so you don't need to memorize them. So we know that this volume is going to be equal to 576 pi. Okay, we know that 1/4 of the whole sphere is 576 pi. And what we're going to do is a little bit of simplifying here, because I can say that 1/4 of this, the 4 here and here are going to cancel, and I can divide both sides of the equation by pi as well. So what I get left with is the 1/3 r cubed equals 576. So r cubed is going to be equal to 576 multiplied by 3. Obviously, the opposite of 1/3 is to multiply something by 3. So on my calculator, I'll do 576 multiplied by 3. So r cubed is 1728. And to find out what r is, I will do the cube root of 1728. And let's see what that is when we put that on the calculator. So I'm going to do the cube root of 1728. And we actually just get the answer that the radius is 12. So now I know that the radius is 12, I'm going to try and find out the surface area of the sphere, of the shape that we've got. Now there's a few different bits. We've got this part of it, and that bit that we've got there, that is a semicircle. We've then got another section here, which is going to be a semicircle. And then we've got this part here, which is the curved part. And this curved part is 1/4 of a sphere. So to find out the surface area of S, so the surface area of S is going to be equal to, well, I've got 2 semicircles. 2 semicircles is going to be just 1 circle that we've got together. So it is just going to be pi multiplied by the radius squared. And then I'm going to have 1/4 of this curved surface area. So I'm going to have 1/4 of the curved surface area, which is 4 pi times by the radius squared. Now there's a bit of simplifying that can be done here. 12 squared is 144, so I get 144 pi. This 1/4 of 4, well, the quarter and the 4 cancel, so I just get another 144 pi. And 144 pi plus 144 pi is 288 pi. It didn't want it in terms of pi, so I'm actually just going to type that in the calculator, and I'm going to give it correct to 3 significant figures. So that's 288 pi, and that is 905 to 3 significant figures. So that is 905 centimetres squared for that one. Let's double check that we've got this one right. Yep, there we go. We've got the 905 in that question. Okay, this one I think is a little bit more simple. It's only 2 marks. It says the diagram shows a hemisphere with diameter 8.4. Well, as soon as I see the diameter is 8.4, all of these formulae use the radius. So the radius is going to be 4.2. It wants us to work out the volume of the hemisphere. So the volume, in this particular case that we've got here, sorry, it just jumped a page, the volume is going to be 1/2 of the volume of a sphere, which is 4/3 pi times the radius squared, and the radius squared is 4.2, so it's 4/3 pi times the radius squared. All I need to do is type that into my calculator, and I've got my answer. So I have 1/2 multiplied by 4/3 multiplied by pi multiplied by the radius, not squared, the radius cubed. I didn't read the formula carefully enough. Let's just correct that we've got here. Cubed. So I'm just going to make sure I type that in with it being cubed. And we get to 3 significant figures. It is 155 centimetres cubed, and that is 3 significant figures. Let's double check we've got that one right. So yep, we do have the 155 that we get there. We did get that one correct for those 2 marks. Okay, so this question, we've got two shapes that are stuck together. We have a cone on top of a hemisphere, and again, they've given you the formula of a cone and the formula for the volume of a sphere. And it says the height of the cone is 10, and the base of the cone has a diameter of 6. Well, as soon as I see the diameter is 6, I want to write down that the radius is 3, and the hemisphere has a diameter of 6, which means it also has a radius of 3. The total volume of the shape is k pi centimeters cubed, where k is an integer. Work out the value of k. Well, basically, they're just saying find the volume of the shape, and then we'll figure out what k is. So I'm going to start off with the volume of the cone there. The volume of the cone, we're just going to use this formula at the top, is 1/3 multiplied by pi, multiplied by the radius squared, multiplied by the height, and the height we can see on the diagram is 10. It's the same as what's being compared on that part. Now, this is non-calculator, so we'll be careful here. That's 1/3 pi multiplied by 3 squared times 10. That's 9 times 10, which is 90. And 1/3 of 90 is 30. So we have 30 pi for the cone. Now we're going to do the hemisphere. Okay, for the hemisphere, we're going to take the formula for the volume of a sphere, and I'm going to half it. So I'm going to do a half of 4/3 pi r cubed. And the radius is 3 cubed. So what I'm going to do is I will think about 3 cubed first of all. 3 cubed is going to be, I'll tell you what, why don't I think of this part? A half of 4/3, well this is 4/3, half of that is 2/3, or you can do 4 times 1 divided by 2 times 3, and 4 over 6 is 2/3. So I have 2/3 pi multiplied by 3 cubed. Well, 3 cubed is 3 times 3 times 3, which is 27. So what I need to do now is find 2/3 of 27. Well, 1/3 of 27 is 9, and times that by 2, and I get 18. So it is 18 pi. So my last part is to find the total volume. So the total volume is going to be the 30 pi plus the 18 pi, which is 48 pi. So by comparing that to the k pi that we have here, clearly k is equal to 48. Let's double check that we've got this one right. Yep, we do have the k being equal to 48, and it's just the two volumes sort of together and then added up. Okay, this time we're looking at a cube and a sphere. It's a non-calculator paper, and it's talking about surface area. It says the surface area of the cube is equal to the surface area of the sphere. So the surface area of the cube is saying find the area of one of these sides and basically multiply it by 6, because we've got 6 different sides. So one of these faces that we have here, well, it's x centimeters on one side and x on the other. It is x squared. And because there are 6 faces, we're going to say that there are 6 faces, so it's going to be 6x squared. So the surface area of the cube is 6x squared. And now we're going to find out what the surface area of the sphere is. Well, they tell us that it's 4 pi r squared. So it's going to be 4 multiplied by pi multiplied by this radius that we have here, which is 3, multiplied by 3 squared. And this thing is the surface area of the sphere. So what I'm going to do is keep solving this equation. I get 6x squared is equal to, well, that's 4 pi multiplied by 9. 6x squared is equal to 36 pi. And they've said show that x is equal to the square root of k pi. So I'm going to find out what x is equal to. I'm going to divide by 6 so that x squared is equal to 6 pi. And then I'm just going to do the square root on both sides so that I get x is the square root of 6 pi. And in this particular case, that means that k is equal to 6. Just by comparing it to that thing that we've got up there, clearly the value that we've got next to pi is 6. So let's double check we've got this one. Yeah, it did say, it said that k, I didn't say that k is equal to 6, but we do end up with the fact of 6 pi or k being equal to 6. So we've definitely got that one correct. I would say this is probably the hardest question that I've come across for a while and doing all of these videos. I think this is pretty challenging because there's just so many layers of things that need to be done, but hopefully my explanation will mean that you can follow what is going on. So it says the diagram shows a sector OACB, which is this thing that we've got here, the sector of a circle with centre O, and the point C is the midpoint of the arc AB, just saying it's over here, like kind of opposite where O is. The diagram also shows a hollow cone with vertex O. The cone is formed by joining OA and OB. So these bits here are going to get stuck together, and it goes from being like a flat circle into a 3-dimensional cone. The cone has a volume of 56.8 centimeters cubed and a height of 3.6. Immediately, I want to label on this diagram that the height is 3.6. I could have labelled it on the side like it does in this diagram, but I'm going to put it in the middle here. It wants us to calculate the size of angle AOB of sector OACB. So it wants us to find this angle that is on that side over there, and I'm going to call it X for now, and it says give your answer correct to 3 significant figures and you must show all your working. Well, the key thing here is that this is being moved or being folded up to make this kind of 3-dimensional cone that we've got here. So I'm going to begin by using this fact that they've told us. Maybe that will tell us some extra things that we've got going on over here. So I'm going to start doing some volume calculations up here. So we know that the volume of the cone is 56.8, and we also know that the volume of the cone is this formula, which is 1/3 times pi times the radius squared. Now, I actually don't have what the radius is here. This is the radius, and I don't know what it is, so I'm going to include it as the radius squared, and it is being multiplied by the height, which is 3.6. So I think I could find out what the radius is. I don't know how that's going to be useful at the moment, but I'm going to just do it and see if it will somehow link forward. It seems like the only thing I can do. So to solve this equation on my calculator, what I'm going to do, once I just clear this bit here, I'm going to do the 56.8 to try and sort out what's going on over here. I'm first of all going to times it by 3 to get rid of the third. Then I'm going to divide it by pi to get rid of that. And then I'm also going to divide it by the height, which is 3.6. So that I get that the r squared is equal to 15.06666. And so that's what r squared is equal to. So to find out what r is equal to, I'm going to do the square root of that on my calculator. And I'm going to write a few decimal points here. I'm going to say that the radius is 3.88158, just in case I need some of those extra bits at the end. So now I've actually worked out that this value is the radius. I'm going to just quickly erase this bit down at the bottom. And I'm now going to say that it is 3.88158. And I'll highlight that to make it clear that this thing is going to be used in this part. Now, I know that the area of this section is going to be the same as the curved surface area of this section that we've got here. So maybe that's going to be something that I can do, because they seem to have given me 2 formulae. So if I find the curved area of this cone, it will be the same as the area of this thing that we've got. But in order to do that, we need to use pi r l. We need r and we need l. In other words, we need this thing, which we don't have. So I'm going to try and find out this part. This is going to be my l. And I'm hoping that you can notice this is going to be a right-angled triangle. So I'm going to use Pythagoras. Now, when I use Pythagoras, to find out what L is, I'm going to do the square root of the 3.6 squared plus the thing that's on my calculator, which is my 3.88158 squared. But I'm just going to use that as the answer button. So putting my calculator back to this side that we've got, I'm now going to do the square root of, let me just press equals here, I'm going to do the square root of 3.6 squared plus the thing that's on my answer squared. So that tells me that the slanted height is 5.29402, just to a few decimal places that we've got there. So now I'm going to get rid of this, I'm not going to get rid of, but I'm going to add that this number is this length that we have over here, which is 5.29402. So I'm going to say that that's what the length is. Now, if I find out what the curved area of the cone is, it's going to be the same as this. So I'm just going to write down that the curved area is equal to the sector area. And I'm going to do one big equation for this. Now, let me put this just a little bit lower down so I can sort of show where everything is going to be. I'll do it here, okay? So the curved area is going to be this part here. It is going to be pi times by the radius, which is 3.88158, times by L, which is 5.29402. Now that is equal to the sector area. Now the area of this sector is going to be some angle, the thing that we're looking for, x, some angle out of 360 multiplied by the area of the whole circle. Now the area of that whole circle is pi multiplied by the radius squared. Now the radius of this circle is going to be the length between O and A, which is actually this slanted part that we've got. So I'm not going to call it the radius. I'm actually going to say that it is my 5.29402. 402. That radius here, this slanted part, is this part that we've got. So if I just put that into the equation that we have, that's 5.29402 squared. Now I'm going to try and solve this equation. I'll show you what I'm going to do on my calculator. I'm going to begin by typing all of this into my calculator. I might do one sneaky thing first actually. Because I have pi here and I have pi here, I'm going to divide both sides by pi to kind of get rid of it. That's going to save me typing at least one extra thing into my calculator. So I'm going to type this thing first of all. So that's 3.88158 times 5.29402. And now I'm going to get rid of this divide by 360 by multiplying by 360. And I'm going to get rid of this multiplying by 5.29402 squared by dividing by 5.29402 squared. And that's going to give me straight away that the answer for x to three significant figures is 264. So we get that x is equal to 264 degrees, which is pretty difficult. I think there's quite a lot of stuff that goes on in this question. And so to two significant figures, we've said that the angle AOB, which is clearly labelled on our diagram as x, is 264. I think that's a really challenging question. I think there's a lot going on in that one. Okay, now we have this one. It says the diagram represents a solid cone. The cone has a base diameter of 20 and a slant height of 25. A circle is drawn around the surface area of the cone at a slant height of 10 centimetres above the base. The curved surface area of the cone above the circle is painted grey, which is this section. Work out the curved surface area of the cone that is not painted grey. So we want this part that's at the bottom. And you must give your answer as a multiple of pi. Okay, well, I think we should probably begin by looking at the large cone. I think the large cone is probably going to be the easiest thing to do. So if we have a look at the large cone, because if we find the, sorry, let me start again. If we find the surface area of the large cone and of the small cone, I can do the large cone minus the small cone, and it will give me the non-shaded part that's at the bottom. So the curved surface area of the large cone is going to be pi multiplied by the radius. Well, this 20 that we've got here, we're going to say that the radius is going to be a half of that, which is 10. So it's going to be a pi multiplied by 10 multiplied by the slanted height, which is 25, which is 250 pi. Now what we're going to try and do is the small cone. This is the harder part, okay? So I'm going to draw something that I hope might help us see what's going to go on here. The large cone has a 25 and a 10. We're now going to try and think of what is happening on the small cone. Well, this slanted part is going to be 15. So why don't I draw the large one, looks like this. This is like a kind of cross section of it where there's a 25 and the radius is a 10. And the small one has got a 15 along the slanted part here. And we're going to try and find out what the radius is along the bottom. Well, these two triangles are similar triangles because they share all of the same angles. So we're going to think, how do I go from 25 to 15? Well, I can find out how to go from 25 to 15 by doing 15 divided by 25. 15 divided by 25. That tells me that to go from 25 to 15, it is multiplying by 0.6. So the radius is also going to multiply by 0.6, and 10 by 0.6 is 6 centimetres. So for the small cone that we've got here, we're going to do pi multiplied by the radius, which is 6, multiplied by the height, which is 15. And you can do this on your calculator, but 6 times 15, I know that's 90. So it is 90 pi that we've got here. So what we need to do now is to find the shaded area of the shaded area. That's going to be the large one, which is 250 pi, minus the small one, which is 90 pi. And 250 take away 90 is going to be 160 pi. And the units for that would be centimetres squared. So the key thing is that we had these similar shapes going up here, and that was because of the triangles sharing the same angles. So we do have the 160 pi, and yeah, that's how that one should be answered. Okay, this time we have got something which is a lot of numbers that need to be done. I think this is the last one that we've got here, and this is about density. So it says here is a frustum of a cone. Again, they've given us the formulae. A frustum is where you have a cone and you take off the top part. You kind of like slice it directly horizontally across. The diagram shows that the frustum is made by removing a cone with height 3.2 centimetres from a solid cone with height 6.4 centimetres and base diameter 7.2 centimetres. The frustum is joined to a solid hemisphere of diameter 7.2 centimetres to form the solid S shown below. The density of the frustum is 2.4 and the density of the hemisphere is 4.8. Calculate the average density of solid S. Well, I could have put this in the density section, but for me it made more sense to be in this volume section because it's just a lot of difficult volume stuff to begin with. But at the very end, we're going to be trying to find the average density. Now, quick reminder of density, it goes mass, density, volume. So when you're trying to find the average density, we are going to do the total mass divided by the total volume. And so that's really what we're aiming to do. We're going to try and find out the volume of both of these things and then go from here. So I'm going to begin by saying if this one up here is volume 1, the volume of the frustum, the volume of volume 1 is going to be the volume of the big cone minus the small cone. So the big cone is going to be 1/3 pi, the radius squared. Well, the radius in this case is going to be 1/2 of 7.2, which you can check on your calculator is 3.6. So that's going to be 1/3 pi times 3.6 squared times by the height of the whole thing, which is 6.4. And then what I'm going to want to do is remove the volume of the next cone. Now, if this cone that we've got here, if it's half of the height, because instead of it being 6.4, it's 3.2, the radius is also going to be 1/2. So the radius from here to here is going to be 1/2 of 3.6, and 1/2 of 3.6 is 1.8. And that's because the height is 1/2, so it's 3.2 out of 6.4, so the radius will also be 1/2. So I'm going to minus from that 1.8 squared, and the height is going to be halved, which is 3.2. So I'm going to work out the volume of this, which is just an annoying amount to type into the calculator. So I'm going to do 1/3 pi times by 3.6 squared multiplied by 6.4 minus 1/3 pi multiplied by 1.8 squared multiplied by 3.2. And so we get the volume of this shape is 76.0014 centimetres cubed. Now, while I'm at it, I'm going to need to find out what the total mass is. So I'm also going to find the mass of this first object, M1. And M1 is found by doing the density multiplied by the volume. We've got that the density is 4.4. So because it's going to be the density times by the volume, I'm going to do the 2.4 multiplied by my 76.0014 so I can get what the mass is. So I've already got that stored in my calculator, so if I times it by 2.4, I get that the mass is 182.40. That's going to be enough for me to do there. Now I'm going to call this, the hemisphere that we've got at the bottom, I'm going to call that part V2. So the hemisphere, which is V2, the volume is going to be 1/2 of the volume of a sphere. So it's going to be 1/2 of 4/3 pi times r cubed. Now the radius is going to be 1/2 of that, which is 3.6. So it's going to be that multiplied by 3.6 cubed. I'm going to get that all typed into my calculator and see what we've got. So I'm going to do 1/2 of 4/3 pi times 3.6 cubed. And we get that the volume is 97.71609 blah blah blah. So I'm just going to write it as that. That's more than enough that we've got there, and that's in centimetres cubed. So I'm going to find the mass of that shape by again doing the density times the volume. Now the density is 4.8, so I'm going to do 4.8 multiplied by my 97.716, and when I multiply those together, I'm going to multiply that by 4.8. I get that the mass is 469.037 grams. So I'm actually now going to be able to go straight to finding out what the average density is by using this formula. It is going to be the total mass divided by the total volume. So the total mass is going to be this one and this one for the mass, and the total volume is going to be this one and this one added together. It's just all going to get put into the calculator. So 182.40 plus 469.037, all divided by the volume calculations, which are going to be my 76.0014. I've done a lot of decimal places there, so I know it's going to be accurate. I'm going to type that all in and see what we get. So, as a fraction, we're going to have the 182.40 plus 469.037, all divided by 76.0014 plus 97.716, and we get to, what does it want it to doesn't say to any particular thing. I'm going to give it to 3 significant figures. I'm going to do 3.75, 3.75, and the units of that are going to be grams per centimetres cubed. Grams per centimetres cubed, and that is to 3 significant figures. A very, very challenging question that we've got there. I'm just going to highlight that those are the volumes that we have, and those are the masses. I need to double check we've got this one right. So is it 3.75? Yep, 3.75, but they accept anything between 3.7 and 3.8. Now, I think that is a very challenging set of questions on surface area. You'll see how it blends with some other things like similar shapes, and in this one it blended with some stuff to do with mass density and volume. If you found this useful, please do just like the video or subscribe to my channel, share it with a friend, anyone who might be doing their GCSEs right now, because I would like as many people as possible to be able to use these videos and to help them with their studies. Good luck!